Hi, this is part J of question 1 on Math 2017. So here we need to work out which of these integrals has the largest value, and thankfully we're not expected to calculate the exact value of any of these integrals. Okay, so because we don't have to find any exact values, we can just try and find some bounds on these integrals and compare those instead. And actually to do that we just need to find some bounds on the integrands, so the things that we're integrating over. Because say we were trying to find the integral of some function like this between these two values, then that's just the area under the curve, right? And if we were trying to find a lower bound on this area, then if we took the function to be equal to its minimum value everywhere over this interval, then this area would be a lower bound. And if we were trying to find an upper bound, if we took the function to be equal to its maximum everywhere over this interval, then this green area would be an upper bound on that integral. So we have that a lower bound on the integral is just the minimum value multiplied by the width of the interval, and an upper bound is just the maximum value multiplied by the width of the interval that we're integrating over. Okay, so first of all, sine to the power of 100x and also 3 minus sine x to the power of 6, because they've both been raised to even powers, they're never going to be negative, and therefore the integrals are always going to be greater than or equal to 0. But when we look at, for example, a, so sine to the 8 is always going to be greater than or equal to 0, but over the interval that we're looking at between 0 and 2, x squared minus 4 is going to be less than or equal to 0. Therefore, overall, what we're integrating over is going to be less than or equal to 0 everywhere within this interval, and so our integral itself is going to be negative. And similarly, sine cubed minus 1 is going to be less than or equal to 0 everywhere, and so our integral is again going to be negative. Therefore, seeing as how we've got two negative integrals, but we know that some of these at least are positive, a and e are not going to be our answers. Okay, so now we just need to compare the rest of these. So starting with b, cos x and sin x both take values between minus 1 and 1. So for b, 2 plus cos x is going to be between 1 and 3, and so 2 plus cos x cubed is going to be between 1 and 27. And the width of our interval is 2 pi, so our integral, which I've just written as b to save writing the entire thing out, its minimum is going to be 1 times 2 pi, so 2 pi, and its maximum is going to be 27 times 2 pi, which is actually 54 pi, not 27 pi, sorry. Okay, so now looking at c, so sine to the 100x is going to be between 0 and 1. And so because our interval has width pi, the integral c is going to be between 0 times pi and 1 times pi. And already we see the upper bound for c is less than the lower bound for b, so b is definitely going to be bigger than c. So we can rule c out as an answer too. And now finally for d, so again remembering that sine x takes values between minus 1 and 1, 3 minus sine x is going to be between 2 and 4. So 2 when sine x is equal to 1 and 4 when sine x is equal to minus 1. And the width of our interval is pi. Okay, so now finally for d, so remembering again that sine x is between minus 1 and 1, 3 minus sine x is going to be between 2 and 4. So 2 when sine x is equal to 1 and 4 when sine x is equal to minus 1. So 3 minus sine x to the power of 6 is going to be between 2 to the power of 6, which is 64, and 4 to the power of 6, which I haven't bothered to work out. So again, because the width of the interval is pi, then we see that the integral d is going to be between 64 pi and 4 to the power of 6 times pi. So we see that the lower bound for D is greater than the upper bound for B, Therefore, D is definitely going to be greater than B. So our answer is going to be D.